All right, greetings everyone. The purpose of this video is to cover some of the problems from section 3.4 over partial fractions. I shouldn't say the purpose of this video, the purpose of a series of videos that will follow. So this video will go over one problem and there will be other videos going over other problems. And as I'm recording this today on Star Wars Day, May the 4th. So I thought a Star Wars themed meme would be appropriate. So I'll give you a second to look at and laugh at this. No, go ahead, I'll wait. All right, so let's take a look at this problem here. So we're asked to evaluate this indefinite integral by using a partial fraction decomposition. And the way we do this is we first go ahead and factor that denominator, because we noticed that x squared minus 4, that's our difference of two squared forms, difference of two squares forms, so that x squared minus a squared. And so we know that factors into the form x minus a times x plus a. So we can go ahead and rewrite this integral as the integral of x over x minus 2 times x plus 2. And then we put our dx back in there since we're integrating. Okay, and then from here we can go ahead and do our partial fraction decomposition. So we see that there are two factors in the denominator there, which means that we're going to break our function there, or I'll call that function g of x, this one here, into two separate pieces. So we're going to have something along the lines of x over the x minus 2 times x plus 2 being set equal to some letter a over the first part, so the x minus 2, plus some letter b, some number b over the second part, which is the x plus 2. And so what we have to go through here is solve for the values of a and b. So to do that, the first thing we need to figure out is a common denominator between our two denominators here. So between x minus 2 and x plus 2, our common denominator would be the product of those two. So it'll be x minus 2 times x plus 2. So write that as the denominator for both fractions. And then for each fraction, we think about what do we have to multiply the given thing by to get the common denominator. So in the first case, we have to multiply x minus 2 times x plus 2. So we do the same thing on the top. So we take the value a, we're going to multiply that by x minus 2. Then we're also going to take the value b here. And in this case, we're going to multiply that by x plus 2. Since we noticed that our original denominator up here was x, excuse me, I have that backwards. I have both of those backwards. I apologize for that. I know you were saying something about it as you're watching the video. I just couldn't hear you. So sorry, this first one should be multiplied by x plus 2. Since the original denominator was x minus 2, we had to multiply by x plus 2 to get the common denominator. The second one here, we have an x plus 2. And so we had to multiply by x minus 2 to get our common denominator here. Okay, I apologize for the mix up there. Now we do some simplifying. So we distribute the a into here, the b into here. So this will become ax plus 2a over our common denominator x minus 2 times x plus 2, plus distributing the second one, we get bx minus 2b all over x minus 2 times x plus 2. Okay, and now that we have the common denominator, we can combine the numerators there. So we can combine this with this. As we do this, I'm going to collect some terms that have the same thing in them. So we have an ax and a bx. So I'm going to go ahead and write those both first. So we have ax plus bx. And then we have two terms that do not have any x's in them. So we have the 2a and the minus 2b. So I'm going to write those second. So plus 2a minus 2b, excuse me, all over, again, still our common denominator, x minus 2 times x plus 2. Okay. All right, and then we'll just do one more little simplifying piece here. We notice that in between the first two terms in our numerator, the ax and the bx, they have the x in common, excuse me. So we'll go ahead and factor that out to the right. So this will become a plus b times x plus 2a minus 2b all over x minus 2 times x plus 2. All right, so now that we've got that all worked out and it's simplified as much as we can, we want to take it and set it back equal to the original thing we started with, this x over x minus 2. So I'm going to go ahead and clear some stuff out here. And we're looking at the point again where we have x over x minus 2 times x plus 2 equals that last thing we just had. So the a plus b times x plus 2a minus 2b, all divided by the x minus 2 times x plus b, or x plus 2, excuse me. All right. And in order for these two fractions to be equal, we know the numerators have to be equal, so x has to be equal to this thing here. I'm also going to rewrite the numerator on the left, since I noticed that the one on the right has terms with x's and terms without. I want to write this in a similar way. And I'm also going to put in a coefficient for the x. So then I know that another way to write just x by itself is 1x. And then on that left-hand side, we don't have anything being added to the x. So to put a placeholder for that, I'm going to put plus 0 equals, we still have the a plus b times x plus 2a minus 2b. And in this point, to solve for the values of a and b, we can set pieces that are in the same place on each side of the equal sign equal to one another. So we'll take the a plus b here, that's next to the x on the right-hand side, set that equal to the equivalent thing on the left-hand side, which is the 1. So I have a plus b equals 1. And then the plus 2a minus 2b, that's the part without x's. That's going to be set equal to the equivalent thing over here on the left, which is the 0. So I have 2a minus 2b equals 0. So now we have two equations with two unknowns. So we can go ahead and solve for those. I'm actually going to start with the second equation here and isolate one of the variables in terms of the other. Since it's set equal to 0, it seems like that might make things simpler. So I have 2a minus 2b equals 0. I'm going to add 2b to both sides. Cross these out, we end up with 2a equals positive 2b. If I divide by 2 on both sides, we end up with, looks like we get a equals b. Okay, which is useful because it tells us that once we solve for the value of one of the variables, we'll know what the other one is. So now we're going to take that information, the fact that a equals b, I'm going to take that and plug it in for a in the other equation. So instead of having a plus b, this will become b plus b equals 1. So then we'll have 2b equals 1, which if we divide both sides by 2 there, we'll end up with b equals 1/2. Okay, so we know the value of b is 1/2. Again, recall that we have backaways that a equals b. So since b equals 1/2, we know a also equals 1/2. All right, and so now we can write our partial fraction decomposition for our given function. So I'm going to go ahead and erase the ink again. So using that information that we just had, again, that a and b both equal 1/2, we know can rewrite our function as 1/2 over x minus 2 plus 1/2 over x plus 2 dx. In this case, both parts of this integral are now in pieces that we can integrate a little bit more straightforwardly using techniques we've learned. So first of all, we know that because we have two terms being added on the inside of the integral, we can break this into two integrals. So we can do the integral of 1/2 over x minus 2 dx plus the integral of 1/2 over x plus 2 dx. And then I'm not going to go through all of the steps from here, but notice in both integrals we can factor out the constant. We can then use substitution to solve these. And when we do that, we'll end up with our final answer here being 1/2 times ln absolute value of x minus 2 plus 1/2 times ln of absolute value of x plus 2. And of course, since it's an indefinite integral, we have our plus c there at the end. Okay, and that's the answer for that one. Thank you so much for watching.